Here's some conics problems from the exam review. Let me do 3 from the 2010 exam, and then if I have time we'll do some more. One is find the vertex, focus, and directrix of the parabola. So that's nice that they tell you it's a parabola. Sometimes you're going to have to figure out. But of course, for directrix, for us, it makes more sense if it's a parabola. It's a parabola because it's y squared and there's no square in x. So we need to find the relevant parameters here. Well, let's write down the standard form that we're trying to match. It's a y squared type, so it's going to be y minus k squared equals 4p times x minus h. It's really just y squared equals 4px, but with a shift in the y and in the x. So that's what we're trying to match. All right, so we're going to need to complete the square in y. Good. That's what we should be doing a lot of. So let's go back to here. So that's going to be y squared plus 2y, and that's, let's see, let's just put that in parentheses. We're not going to need to do any complicated version of completing the square, but let's sort of pretend that we would be. So minus 6x, and let's just move the minus 13 over. Okay, so that's going to be y plus 1 squared, and then minus 1. Because this is, you take 2 and you take half of that. It's going to be y plus 1 squared would be y squared plus 2y plus 1, and we just subtract the 1 off right away. That's the way I usually do completing the square. Okay, and now we just got to move everything into the right places. We've got y plus 1 squared equals, want everything else on the right-hand side. Well, let's see. The minus 1 is going to turn into a plus 1, so that's going to be minus 12, and then it's going to be 6x. Now, what do we do with the minus 12? We have to really look carefully at what we're matching. It's supposed to be some interesting number, which is going to be 4p, times the quantity x minus h. So we've got to factor out the 6 out of both of these things. So the left-hand side is all set, and we're seeing our shift down 1 with a k equals minus 1. And then it's 6 times x minus 2, and I'm even going to write that as 4 times 3 halves times x minus 2. Okay, so we're getting that k is minus 1, h equals 2, and p is equal to 3 halves. So the vertex, that's the home base. That's really important that it's a home base for the parabola. It's not the home base for the hyperbola or the ellipse. The home base for a hyperbola or ellipse is the center. The vertex is the home base for the parabola, the way we do things. And that means that the vertex is just going to be determined by k and h. It's just going to be, it usually starts out at 0 and 0. We've shifted it down 1 and to the right 2. And so vertex is going to be 2 comma minus 1. And of course it's sideways because it was a y squared equals 4px type. And so the focus is either left or right from the vertex, and the p says it's going in the positive direction. Okay, and the p, remember, p contains the directions on how to get from the vertex to the focus. And so that means that the focus rather, is going to be, you take 2 and you move over to the right 3 halves. So that's going to be 4 halves plus 3 halves, 7 halves, comma, minus 1. Because you're not moving up or down. The focus is straight to the right of the vertex, and so it's going to be 7 halves, comma, minus 1. And then the directrix always just go the other way from the vertex. It's opposite, equal and opposite to where the focus is. And so the directrix, that's the line. Well, let's see. Is it a y equals or an x equals? This thing is opening sideways. I'll graph it in a second. I probably should have graphed it by now. It's opening sideways, and so it's a vertical line. It's going to be an x equals So the vertex was at x equals 2, and then I just go to the left by 3/2. And that's going to be 1/2. Okay, so let's look at this thing. Let's go ahead and graph it. So I'm going to cheat a little bit, let the computer do it. But I want to be able to point at something. So one thing that I should have said at the start, it's a little hard to freehand stuff on the computer here, which is why I didn't do this. But as soon as you get to about this point, you do actually want to just sketch. They didn't say sketch. They didn't say graph. They just said find vertex, focus, and directrix. But you want to have at least a rough sketch graph. Just put some axes on and plot the point -1, 2. And then just as you get these things, actually plot them and see if they make sense. Things like the focus, things like the directrix. Okay. And so here's the parabola. Here's the vertex at 2, -1. And then let me go ahead and put in, let's add in the directrix dotted or dashed. See if that looks reasonable. Okay. And then the focus is going to be at, let's see, let's add a little O, which is the letter I usually use. And that was supposed to be at 7/2 or 3.5 -1. Let's see if that looks good for the focus. So there we go. So there's the vertex, there's the focus, there's the parabola, there's the directrix. And we might as well put in, if we were wanting to graph this, a nice thing to also plot in, one more thing, the axis of symmetry. And put that in as a dashed line too. And that kind of gives us a nice picture of, that's where all these things live. The focus, the vertex lives on the axis of symmetry. The axis is perpendicular to the directrix. So that's a nice complete picture. They didn't ask for it, but that's what, if you can't easily kind of create something like this as you're finishing up this problem, then you're not, almost certainly not doing the problem correctly. Okay, so there's the solution to that one. This one is really easy. First of all, you know it's a hyperbola because they say it has asymptotes. And if they didn't, if they said something like or if we this year said something like find all the features or something coy and ambiguous like that, it's really important that if when you've got a plus x squared and a minus y squared, that's going to be a hyperbola. And the asymptotes are really easy because what we do is we just take this equation and we just replace this with a 0 and we simplify. That's it. That's how I always do it. I don't memorize things with A's and B's and stuff like that. I just remember if you change this to a 0, it sort of makes it the infinitely sort of skinnified version of the hyperbola. It sucks the hyperbola into its asymptotes. And then that's easy to simplify. Why? Because you can move something over and take the square root of both sides. You can move this guy over and then take the square root of both sides. Hey, I can do that just by deleting some stuff. Well, not quite. Don't change that into a 4. And what happens when you take the square root? You get a plus or minus. There you go. You're done. You could solve that for y in terms of x, but it's actually not really that important to do that. I'd accept that, and you're done. Super easy. Okay. Vertex, foci. Let's go ahead. Let me go ahead. It'll take a second, but let me go ahead and do the graph first. Let's see. I need a graph window. So let me just graph it. Just kind of a silly, simple graph here. Okay. So let's see, I'm going to need to change my window here. Let's view it from like -12 to 12, -10 to 10. Just, we could change that if we want. Okay, so I wanted to just plot some of this stuff. -10, 3, -6, 3, and 2, 3. So let me put those in as quickly as I can. -10, 3, -6, 3, Sometimes I do these ahead of time, but not today. And 2, 3. Let's see if that makes sense. Ha! That didn't work, did it? What did I do? I just didn't change that to a 0, I guess. Let's see. Just being in a rush here. Hey, there we go. 2, 3. I thought I put the 3 in, but I won't. Okay. So there's one vertex, and here's the 2 foci. Well, the 2 foci, it's an ellipse, so the other vertex should be over here somewhere, and then the ellipse should go something like this, around this way. Okay, well, how do we do that? Well, as I said, the home base here is the center. We're going to need that. That gives us the shifting. Everything is calculated relative to the center. Let's delete that. We don't need that anymore. And so the center, well, where is the center? It's halfway between the foci. The center, the foci are supposed to be symmetrical around the foci. So that's going to be the midpoint of the segment between the 2 foci. How do you get a midpoint? You just average the coordinates. And so the center is going to be the point, let's see, -6 plus 2 is -4, divided by 2 is -2. And then 3, of course, the average of 3 and 3 is just 3. Okay, that's really key, because everything is really relative to the center. So let's remember, A is equal to the distance from the center to either one of the vertices. We're going to be able to read that off, because now we know the center and we know a vertex. B equals the distance from the center to a minor vertex. That's my personal terminology. In other words, it's equal to 1/2 of the minor axis. Now, we don't have that at all right here, and that's where we're going to have to use our Pythagorean relationship. C, though, we're going to be able to figure out, because that's the distance from the center to focus. Aha. Okay. And this is definitely stuff you should have in your notes, or in your study sheet for the exam. Okay, so do we know this one? A, yeah. From -2, 3 to -10, 3, that's 8. And C, that's from -2, 3 to either -6 or 2, 3, that's 4. Okay. And then B, we can get, that's the square root of a squared minus c squared. Because since we have that a squared equals b squared plus c squared. Remember, this is a little different between ellipses and hyperbolas. Just make sure you write down the right one. You can always check it, because the big one, the thing that's always the biggest, should be the thing that's the sum of the other two. For an ellipse, the major axis is the longest thing. Of these three numbers, the vertex, the minor vertex, and the focus, what's furthest always from the center? It's the vertex. And so that's the only one that makes sense for an ellipse. And so that's going to tell you, just solving for b is what I did here. And so that's the square root of 64 minus 16 equals the square root of 48, which is, there's a 16 in there, so it's 4 root 3. Okay. And what do we want? We want the equation. Okay. So the equation, just going to put that all together, and we're going to get, okay, let's see, x, what was the shift? It was a minus 2, so we're going to get x plus 2 squared over, now let's see. Be careful about the role of a. Remember, a is always along the major axis. We know the major axis is horizontal. It's along this line where y equals 3. And sorry for jumping around so much. And so that's going to go under here. That's going to be the a squared, or 64, plus, because it's an ellipse. And then y minus 3, because that's the shift in y, squared over b squared, which is 48, equals 1. So we had the shift from the center, minus 2, 3, that goes into here. We had the a and the b with a little calculation, or really the a squared is 64 and the b squared was 48 from here. And so that's how we get the equation for that thing. Let's plot it real quick. Oh, actually, let's copy this and then plot it real quick. they didn't ask for that, but let's go ahead and put it in. So there's our, okay, it's going through a vertex. It looks like it has about the right kind of center. Let's plot the other vertex on the center real quick. So let's add a label at, the center was -2, 3. And then we never did find the other vertex explicitly, but it's go from -2, 3, go 8 over, so it's going to be 6, 3. And let's see if we got it. Let's see if I made any mistakes here. Looking good. There's the center. There's the two foci. There's the vertices. We could even plot the endpoints of the minor axis if we wanted to, but it's looking pretty good. Okay, that's good for this video.